Let's look at what we're doing today, which is solving rational equations. Okay, so we've been working with rational equations. We've done multiplying, dividing, simplifying. Today we're going to start working with solving rational equations. So the way we begin this is basically think back to your Algebra 1 solving stuff. So remember the golden rule for solving equations: what you do to one side of the equation, you're going to do to the other side of the equation. So in this case, if we wanted to solve for this 3/2 x minus 1/4 equals 3/8, we can follow these steps to make this easier. We don't want to deal with fractions, so we can eliminate the fractions by multiplying by the least common denominator. So what they mean by that is, if we look at the common denominators, or the denominators of all of them, we can find a multiple that all of these can go into. We can multiply by that and eliminate those denominators. So in this case, we have 3/2 x minus 1/4 equals 3/8. So our least common denominator would be a multiple that all of those can go into. So we got 2, 4, and 8. Well, 2 and 4 can be multiplied together to get 8. 8, of course, is a multiple of itself. So we can essentially multiply every single one of these by 8. Again, what you do to one side of the equation, you have to do the other side of the equation. You got to do to everything. So when we multiply everything by 8, I can then get rid of my denominator. So I have 8 essentially divided by 2, which then leaves me with 4 times 3, which gives me a 12x, minus 4 and 8, gives me a 2 left on top. So 2 times 1 leaves me with negative 2. And then the 8 divided by 8 leaves me with just 3. So we've essentially now turned that into just a linear equation. But before we would cancel out, if we had any variables in the denominator, of course, we would state our restricted values. We just now multiply it by our LCD. So then we want to write it in standard form. In this case, we've just got a single variable, no x squareds or anything. So we can actually just solve for this. Add our 2 over. This is 12x equals 5. Divide by 12. So we get x equals 5/12. And the last step would be, we would want to check for extraneous solutions. Because again, we can get extraneous solutions if by plugging in this value, we have a 0 in the denominator. In this case, we don't have any variables in the denominators, so we don't really have to worry about it. Okay? Our solution works mathematically. So let's look at solving some rational equations. And that one wasn't quite a rational equation, but that's it. So equation number 1, we got x minus 4 over 4. Equals x plus 4 over 8.
Didn't you do it by forming two and slowly solve or would you do it by two?
So least common denominator. So the smallest that we can multiply by is at least the biggest. Okay. So you're always going to look at the biggest first, and you're going to see if this can go into that. So that's kind of the trick. Always start with the biggest, because you're going to have to multiply by at least the biggest one. So is 4 going to 8? So in this case, we can just multiply by our 8 on both sides. And that cancels out with that 8, which leaves us with x plus 4. And then on the left side, we have 8, and we're dividing by 4. So that leaves us with a 2 on top. And then we're going to take that 2, and here's where we've got to think about it. We've got to distribute that 2 to everything that is left in that numerator. So we're going to have a 2x minus 8. So once we've done that, again, we had no x variables in the denominator, so we didn't have any excluded values. But then we need to solve. So to solve for x, I'm going to move my x's to one side, my variables to one side, my constants to the other. So I'm going to subtract x over. I'm going to add 8 to the other side. So 2x minus an x leaves us with x. And 4 plus 8 gives us 12. Again, we can take that 12, plug it back in, make sure it works. 12 minus 4 gives us 8, divided by 4 gives us 2. 12 plus 4 gives us 16. 16 divided by 8 gives us 2. 2 equals 2. Okay? So it's not an extraneous solution. Let's look at our next one. Five over x plus 1 times 8 x plus 1. Okay. What are we going to multiply both sides by to get rid of our denominator? 8. So just like the others, we're going to multiply this one by 8 again. Here's what we need to make sure is put that other one in parentheses. And that leaves us with 5x plus 1. And then we can distribute that. And we're going to distribute this one as well. 8x plus 8. That would be 5x plus 5. And then solve from there. I'm going to subtract my 5x over. And I'm going to subtract my 8 over to the other side. We've got 3x and a negative 3. Divide by 3. And we get x equals negative 1. So then when I plug it in, again, I want to check. For extraneous solutions, we only have the one solution, so it should work out. So we've got 5 times negative 1 plus 1 over 8 equals negative 1 plus 1. Of course, negative 1 plus 1 gives me 0. 0 times anything is still 0. So that's just going to be 0 on the left. Negative 1 plus 1 gives me 0. Checks out again. Okay. Then our last one, now we have equation number 3. We got 1 over 3x plus x minus 1 over 3 equals x plus 1 over 3x. So again, the first thing that we want to do is find our least common denominator. So what's our least common denominator of those 3? 3, and what else is in the denominator? X. So in order to get rid of our denominators, we're going to have to multiply again by at least the biggest thing. Whatever's down there, the most amount, you're going to have to multiply by that amount minimum. Okay? So in this case, 3x. I can multiply all of these by 3x. Now, before we cancel things out, what are my excluded values? What can x not equal? So this is the first one where this is the case. 0, right? Can't have x equals 0. So if we plug it in for here, right, 0 times 3 gets you 0, and you cannot divide by 0. The next step is, now that we've figured out what our LCD is, we want to multiply by that. So we've got 3x divided by 3x. Those two are the same. Cancel out, and we're left with just the 1. So we have our numerator 1 times 1. We'll just get 1 plus, in this case, I have 3x divided by 3. The 3's cancel out. The x stays. So I've got x. I've got to distribute to both. So x times x gets us x squared. X times negative 1 gets us negative x equals 3x divided by 3x. We do the same, they cancel out. And we get x plus 1. So now we need to solve. Well, we've got an x squared this time, meaning we can't solve like we did our linear equations. We're going to have to get everything to one side of the equation to solve. So I'm going to subtract my x over, and I'm going to subtract my 1 over here as well. So that's going to give me x squared minus 2x. By 1 minus 1, that's going to give me 0. equals 0, right? Because everything else on the side canceled. 1 minus 1 cancel. What can we do with x squared minus 2x? We can divide by x, right? We can factor out that x. They have an x in common. So we can take that out. That leaves you with x minus 2. Now that we have it simplified, we can actually take both of these factors and set them equal to 0 and solve. So in this case, I'm going to take x, our first factor, just set it equal to 0. I'm done with that.
X minus 2.
So then x minus 2 equals 0. We're going to add 2 over. So we get x equals 2. So now in these bottom boxes, right, says use these to check for rational equations to make sure we don't have any excluded values or extraneous solutions. Well, we checked for our excluded value at the beginning of this one. We said 0 is excluded. 0 came out as one of our solutions. We cannot have 0 as a solution, right? Because if we plug in 0, 0 times 3 gives us 0 in the denominator. That one doesn't work. So that is an extraneous solution. 2 does work. And again, we can check that. So if we plug in 2 into our original equation, we got 1 times 3 times 2 plus 2 minus 1, or 2 over 3 equals 2 plus 1 over 3 times 2. So 1 plus, or 1 over 3 halves, or 3 times 2 is going to give us 1/6. 2 minus 1 will get us 1/3 plus 3, or equals, plus 2 plus 1 gives you 3. 3 times 2 gets a 6. We can change 1/3 into halves or into 6 by multiplying both the top and the bottom by 2. Essentially multiplying by 1. That gets us 2/6. So 1/6 plus 2/6 gives us 3/6. And that equals 3/6. So it does check out for 2. Okay. So 2 was a true solution. We checked it. It's not extraneous. Any questions on that? So let's pick out some of these problems on the back page. Which of these do you want to do? If we're going 1, 2, 3, 4, 5, and 6. Number 3. We've got x squared minus x 6 over, is that x squared plus x minus 2 over x equals 1 over x. So in this case, what is our least common denominator? X squared, right? It has to be at least the biggest one. X squared is the biggest one. We can turn x's into an x squared by multiplying by x. So what I'm going to do is I'm going to multiply everything by x squared. So in this case, I have x squared divided by x squared. Those two things cancel each other out. And I'm just left with my numerator, x squared minus x. On the second term, x squared divided by x squared divided by x is going to leave me with just an x on top. It's going to get rid of that squared part. Remember, I've got to then distribute. That's probably the most missed thing, forgetting to distribute. So we got x times x, the x squared, and x times negative 2x equals x squared divided by x. It cancels out the squared. We're left with 1x. So x times 1 leaves us with x. Got to do something. What was our excluded value? What can x not equal before we get some 0? Something to remember. So we got to solve for x. We got a bunch of x's. We need to move it all to one side of the equation. So I'm going to subtract x over. And then combine our like terms. So we got an x squared and x squared. Gives us 2x squared. Note those and mark out. Negative x minus 2x minus another x. For x. And then we have that minus 6 equals 0. So what do we need to do to solve this? Well, we can factor it, but what can we do to make this factoring easier for us? Simplify it, take out a 2, right? These all have a coefficient of a 2. So we take that out. X squared minus 2x minus 3. So then, can we factor that? What are my signs going to be when I factor this? Minus plus, plus minus. And then our numbers, -3, 1. So -3 plus 1 gets us -2. -3 times 1 gets us -3. And then the last thing, set our factors equal to 0. I can ignore this 2 because there's no x attached to it. So I'm really just going to look at my x minus 3, my x plus 1. Set those equal to 0 and solve. Again, once you've done this a couple times, all you're really doing is changing that sign. So we're going to get x equals 3. We add it over, and x equals -1. Now, we still need to check for extraneous solutions. It could be true that both of them work. It could be true that only one of them works. It could also be true that none of those work. Right? We said 0 is excluded, but we still want to check to see if those are real solutions or not. Right, so let's plug it in. So let's do 3 first. We got 3 squared minus 3 and 6 over 3 squared plus 3 minus 2 over 3 equals 1 over 3. So 3 squared gets you 9. Minus 3 minus 6 would be minus 9 minus 9, which gives you 0 on the top.
Mr. Hope,
Yes.
I need Aaliyah Nolan to come down the lead, please.
All right.
Thank you.
You're welcome. So 0 divided by anything is just going to give you 0. Plus 3 minus 2 gives you 1 over 3. It's 1/3. So 1/3 plus 1, or 1/3 equals 1/3. That checks out. Then we need to check for -1. We got -1 squared minus -1. 6. -1 squared. Minus 2. -1 equals 1. So plug this one in. -1 squared gets you 1. -1 minus 1 is going to become a plus 1. 6. -1 squared again is 1. Plus -1 minus 2 gets you -3. -1 over 1 divided by -1, which gives you -1. 1 plus 1 would be 2. Minus 6 is going to get you -4 over 1. Essentially minus plus 3, actually. Negative over negative. And -4 plus 3 gets you -1. And -4 divided by 1 is just -4. So -1 does equal -1. Okay. So that also checks out. So both of those solutions are true. Neither is extraneous. Okay. So really today is just a lot of solving work. Okay? You've been doing these things for years and years and years, but you've got to practice these skills. Most common mistakes, dropping negatives, especially when they're squared, and not checking for those extraneous solutions. Any of those other problems you want to look at when you want to get started. Again, find that LCD first. So let's look at a couple of these problems on homework. Let's get you started. So if we're looking at number 1, what would be my LCD for number 1? Read it. Right. We're looking at number 2. To it. That'd be right. Number 3. 2p. Okay. Number 4, what would be our LCD for that? Next one. Any questions on how we're getting those? Again, that's kind of starting us in that right direction on how to solve this. So you guys have 20 problems to do today. Okay. Any questions? Yes.